Hello students, welcome to AbDevi's YouTube platform for class 11-12 physics. Today we will consider a problem from mechanics, laws of motion, MCQ type problem. See the statement of the problem. A piece of wire is bent in the shape of a parabola y equal to kx square, y-axis is vertical. So, a piece of wire is bent in the shape of a parabola y equal to kx square. That means, let me draw the parabola like this. Okay. So, my drawing may be excused. Just once again. Let me try to get the drawing. Something like this. This is a parabolic shape y equal to kx square. Okay. A bead can slide on the wire without friction. So there is a bead which can slide on the wire without friction. It stays at the lowest point of the parabola when the wire is at rest. When the wire is at rest, it stays obviously at the lowest point like this. The wire is now accelerated parallel to x-axis. The wire itself is accelerated parallel to x-axis. This is x-axis and this is y-axis. Y-axis being vertical. And this is obviously origin. Now, wire is now accelerated parallel to x-axis with a constant acceleration a. Wire is moving. The distance of the new equilibrium position of the bead, where the bead can stay at rest with respect to the wire from the y-axis, is a by gk or a by 2gk or 2a by gk or a by 4gk. Which one is the correct answer? So first of all, when the wire is at rest, the bead is at the lowest point of the parabola. That means here, obviously here, and at this point, I can say that there are two forces acting on the bead. One is vertically downward, which is like this. This is the parabola, and this is the bead, you say. This is the origin, and the forces are, one is vertically downward, which is mg, m being the mass of the bead, and there is a reaction force offered by the wire on the bead, that is called r. So in equilibrium, r is equal to mg. When the bead is not, here I am using capital M, so like this. When the wire is at rest, this equation is satisfied and the bead is at the lowest point. Now, when it is moving in this direction, positive x-axis, along positive x-axis with an acceleration a, then what is the position of new point of equilibrium? So, let us assume the new point of equilibrium has a coordinate like this. Bead is at this point and its coordinate is say alpha beta. Okay, and in this part of the parabola. So at this point, when the bead is there, what are the forces acting on the bead? One is vertically downward mg. Another is a reaction force which is perpendicular to the parabola, tangent to the parabola at this point. So let me draw the tangent to the parabola at this point. And the reaction force offered by the parabolic wire on the bead will be along the normal to this point. Okay. Now this particular angle, if I call it psi, then how do I find the value of psi? It is given y equal to kx square. So dy dx is 2kx. So dy dx, this is position you call P. Position of the bead is P, and P's coordinate I have assumed it is alpha beta here in this plane. So dy dx is equal to, at the point P, is equal to 2k alpha. Okay, this is the direction of reaction force. Now, if this is psi, then what is the angle R vector makes with positive x direction? So this angle, if I call it theta, the angle that R makes with positive x direction is, this angle is actually 90 degree. There is no doubt, because this is the angle between tangent and normal to the parabola at the point P. So this angle is 90 degree. So I can write a normal makes an angle theta with positive x-axis. So I can write psi equal to pi by 2 plus theta. Okay. So sin theta, tan theta, if you take, tan psi equal to tan pi by 2 plus theta. So it is negative of cot theta. Tan psi equal to this much. But tan psi is nothing but 2k alpha. Because dy dx at point P is 2k alpha. So tan psi is the gradient of the tangent to the parabola at the point P. So dy dx at P is nothing but 2k alpha. Up to this there is no doubt, I think. So cot tan theta is how much? Is 1 by 2 k alpha with a negative sign. Tan theta equal to 1 by 2 k alpha with a negative sign. Now, what are the forces acting on the bead at this point P? Remember, the wire, parabolic wire, is moving in the x direction with acceleration a. So, one is definitely this force. Mg. Okay, this is the weight of the wire. Then this is the reaction force R offered by the wire on the bead. So it is reaction force R. And since it is, the bead is placed on an accelerated frame, the bead must, when you consider the mechanics of the bead with respect to the parabolic wire, then there must be a fictitious force which is equal to mass time acceleration in the opposite direction. Okay, so there is no doubt because it is an accelerated frame. So here it is m times a in the opposite direction. And since the bead is at equilibrium with respect to the wire, so these three forces must balance each other. So if I take the component of r in the vertical and horizontal direction, so this angle, if this angle is theta, this angle is also theta. So this component of r is r cos theta, and this component of r is r sin theta. Remember, this is the reaction force offered by the wire on the bead itself. Okay, this is the bead. So if this angle is theta, this angle is also theta. So r cos theta is the horizontal component, r sin theta is the vertical component of r. Now, so we can think that there are four forces acting on the bead. One is along positive x direction r cos theta, along negative x direction ma, which is the fictitious force, mass of the bead times the acceleration of the frame itself, which is a, and r sin theta in the positive y direction and mg in the negative y direction. So these forces must balance. So r sin theta must be equal to mg and r cos theta must be equal to me in the equilibrium condition. Therefore, tan of theta is equal to G by A. But tan theta we have already found negative 1 by 2k alpha. Alpha is the coordinate of the point of the bead. You can say center of mass of the bead. It's a point mass sort of thing you can assume. So minus 2k alpha is equal to G by A. So alpha is actually A by 2gk with a negative sign. So it indicates that it will be in the left part of the parabola and whose coordinate is minus a to the k. X coordinate is like this and y coordinate you can find out from this equation. So this distance is magnitude of this distance is alpha and alpha's value is a by 2gk. That means at a distance of a by 2gk, if we move along a by 2gk and if we go vertically up, we reach a point on the parabola. At this point, the bead will be at equilibrium. Okay, so distance of the point from y-axis is a by 2gk, and negative sign indicates that it is in the left part of the parabola. Now the question arises, so this is the correct answer, answer is B. Now the question arises whether if the bead can be at equilibrium if we place it here a point like this. So here what will happen in this position, if we look, then what will happen? The fictitious, since the frame is moving in the positive x direction with acceleration a, so fictitious force will be in this direction on the bead, weight will be in this direction, downward direction mg, and reaction force will be like this in this direction along the normal to the point P. Reaction force will act, and in this situation the system can never be, the bead can never be at rest with respect to this wire, because if I take the components of R, then the horizontal component of R will not allow to remain the bead at rest. So in the right part of the parabola, we can never get a point where the bead can be at equilibrium. It will always be at this point which is in the left part of the parabola. And the distance of this point is alpha, whose value is alpha's magnitude is actually a by 2g t. So a by 2g t is the correct answer. I hope you have understood. It's a very simple problem. Only thing is that you have to take care of this 50 such force. When the body is in the accelerated frame, you should take into account of the 50 such force, which is mass of the object multiplied by acceleration of the frame, and it is acting in the direction opposite to the direction of acceleration. And there are three forces acting on the body. One is the weight mg, or reaction force offered by the wear of the bead, and 50 such force ma. These three forces keep the bead at rest. So we got these two equations, from which we got tan theta equal to g by a. On the other hand, tan theta we derived earlier, it is minus 1 by 2k alpha. So equating these two values of tan theta, we could find the value of alpha, which is a by 2g. I hope the problem is clear. If you have any doubt, you can revert back to us. We will further explain to you. So thank you for your listening. Thank you very much.